Good day, sir. I am Philip Anthony Deloter, presenting compass calculation and sailing calculation. So, what is compass error? Compass error is the horizontal angle contained between true north and compass north. Compass error is named east if compass north lies to the right of true north and west if it lies to the left. Compass error is the algebraic sum of variation and deviation. If variation and deviation have the same name, add. If a different name, subtract, and name compass error same as the quantity of the greater value. Compass error is also the difference between true course and compass course, or difference between compass bearing out true bearing and compass bearing. The difference between compass heading and true heading expressed as the algebraic sum of variation and deviation. So, name of compass error is the first is if variation and deviation of the same name and their values and affix to the result their common name. Second, if variation and deviation of different names, subtract the lesser from the greater value and affix to the result to the greater name. So here is an example to solve compass error calculation. The question is, a case will arise when the deviation of the ship's compass is required. In this case, the name of variation changed to opposite given is compass error is equals to 4 degrees. Variation is equals to 15 degrees east. Find the deviation. So variation is equals to 15 degrees is now west because it is changed to opposite. 15 degrees west minus 4 degrees east is equals to 11 degrees. Deviation is 11 degrees west. Its direction is now west because the rules that we copy the symbol of the higher number. Sailing is a mathematical solution of problems involving finding courses and distance from one point to another. For short distance, these problems are easily solved directly on charts. But for long distance, mathematical solutions is often better method. Kinds of sailing. There are 5 main types of sailings. Some authors say the 7 types, but the other 2 is just modification of the main types. First is the plain sailing. It solves problem solving in a single course and distance. Difference of latitude and departure in which is regarded as a plain surface. Second is parallel sailing. It is the interconversion of departure and the difference of longitude when the vessel is proceeding due east to or due west. Their middle latitude sailing is it uses the mean latitude for converting departure to difference of longitude when the course is not due east or west. It combines plain sailing and parallel sailing. Fourth is sailing, Mercator sailing. It provides a mathematical solution of the plot as made on Mercator chart. It is similar with plain sailing but uses meridional difference and difference of longitude in place of difference in latitude and departure. Last is great circle sailing. It involves the solution of courses, distance, and points along a great circle track between 2 points. The other 2 sailings, which are the modifications of the above main type, are the following: traverse sailing and composite great circle sailing. Traverse sailing, it is combines the plain sailing solutions when the 2 or more courses and determines the equivalent course and distance made good by a vessel along the series or ramp line. Composite great circle sailing is a modification of great circle sailing to limit the maximum latitude. General to avoid ice or severe weather near the poles. The sailing calculation that I choose is plain sailing. It is sailing along the track in which the initial position and the final position are not in the same latitude. Small areas of Earth's surface can be assumed as flat. Plain sailing is limited to 600 nautical miles only. Formula of plain sailing is cosine m lat is equal to departure divided by d long. Thumb rule of m lat is that if same hemisphere you add, but if different hemisphere you subtract. So if hemisphere, the formula is latitude A plus latitude B divided by 2. Different hemisphere formula is lat A minus lat B divided by 2. So let's move on plane sailing calculations. Our initial position and final position is already given, and we must find out the course and distance. So first we're going to do is find the lat. So lat 1 is 60 degrees 11 minutes north. We subtract it by lat 2, which is 55 degrees and 10 minutes north. So our d lat is 5 degrees and 1 minute seconds, or 301 minutes south. Second to do is find our d long. So long 1 is 76 degrees 44 minutes west. Subtract it by long 2, which is 80 degrees 16 minutes west. Our d long is 3 degrees 32 minutes west, or 212 minutes west. Third is to find our m lat. So 60 degrees 11 minutes north, subtract it by 55 degrees 10 minutes north, equals to 115 degrees 21 minutes north. The answer to this is we divide it by 2. So our m lat is 57 degrees and 40.5 minutes north. Now since we have the d lat and d long and m lat, next to do is to find the departure. The formula that we are going to use is departure is equals to d long times cosine m lat. So 212 minutes times cosine 15 degrees for 40.5 minutes is equals to 113.4 minutes. Our departure is 113.4 minutes west. Next to do is our course. The formula that we're going to use is tangent course is equals to departure divided by d lat. 113.4 minutes divided by 301 minutes equals to 0.3767. Then we can use our calculator by inputting shift tan to 0.3767, and the answer is 20.64 degrees. Converting it into degrees and minutes, and the answer is